Hey everyone, welcome to this channel. Today we will be diving into the world of non-parametric statistics and exploring the Wilcox Signed Rank Test. This powerful test helps us compare two related samples and assess if their median differs significantly. We will be implementing it in Python. So, how to perform the Wilcox Signed Rank Test in Python using Scipy and Penguins library. This is our today's video. Wilcox Signed Rank Test is a non-parametric alternative to a pair t-test. It doesn't assume normality in the data distribution and focuses on the rank of the difference between two paired and dependent samples. So let's have a look in the data. We have a data set. In this data set, we measure the blood pressure before and after the treatment of a group of individuals. Our data look like this. Here we have a subject, and subjects have twice readings before and after. The values indicate that the blood pressure is taken before and after the medication. So first we import here our libraries like an import pandas as PD, and we also import from Scipy, import stats, and we also import from scipy.stats import Wilcoxon test, and we run this code of the chunk. Now we have to read our data. For reading a data, we write here data underscore pressure. This is our vector, and we say to read this data using a pandas function pd.read underscore excel, and open the bracket, double quotes, and we just give the name of the file. We test this, and data on this file exists on a sheet name equals to 1, and we just run the code here. Without error, we got reach here, and we can see our data, how it looks like, data underscore pressure. And we can see here we got our subjects, blood pressure before the medication and blood pressure after the medication. And we have here a total number of readings are 25. So now we check the normality of the data. As we know, to perform any task, we first check the normality. So here we do a normality check for both the samples, like before and after the reading. So here we say stats.shapiro and open the bracket, and here we say data underscore pressure. We open the bracket and we provide here our first before readings. We got here this, and we want from the Shapiro test that it will provide us statistics and the p-value for the data. So we write here statistics comma p underscore value, and we put the equal sign to get the statistics from there. And here, and we just run the code chunk here. So it says us it got it statistics and p-value, but we need to print the results of the Shapiro test. So we write here print, open the bracket, double quotes, we just write here Shapiro results, and here again we write print, open the parenthesis, and in this we write here statistics colon sign, and we just gave here comma and again stat, and the same we will do for the p-value. To print the p-value, and print, open the 8 double quotes p underscore value, and we give the colon sign, and here we just write p underscore value. So now we have this, and we run the code here. Yes, I forgot the comma here is right, and we just run the code, and we can see here we got the Shapiro results statistics 0.97 and the p-value 0.69, which is really higher than the 0.05. So we can say for the blood pressure samples before the medication, the data was normally distributed, and we can repeat this is the same code. First we copy here and we insert the code here, paste here, and on this place before we just write an after, and all the code will stay same, and after will showing that we are taking a data blood pressure samples after the medication. So we just click here and run the code, and we can see here we got a statistics of 0.91 and p-value is 0.04, which is slightly less than our 0.05 value. Like this, we say that our data, in this scenario, we choose to perform a Wilcox Signed Rank Test. So here we write one markdown and we just write here Wilcoxon Signed Rank Test, and now we have a code here, and to perform the Wilcoxon Signed Rank Test is our first method using Scipy library. So here we will perform a very simple things. We just say from stat import, we already imported the Wilcoxon test from stats library, and we just write here, open the parenthesis, data, our data, and in the data we have our samples before the reading and after the reading. So we just write here in a double quotes after, and we comes out and put in a comma sign here, and again repeat the same for the before the samples, and put bracket and double quotes and before, and we just came out and put here comma, and because the samples must be of two-sided, so we say the alternative equals to, in a double quote, two hyphen sided. And method, what kind of method we need? We need a method here, exact, perform the, to calculate the p-values. So method equals to exact, but here in this we have to come in the start and write what it gives us as an output. So to as output we need a statistic, comma, again the same as a p underscore value, and we just put here the equal sign, and we run the code here. Okay, I make a mistake here. We need here the double quote because I forward, and we just run the code, and we can see we have a result, but we need to print the results of the task. So we comes here and we just write the same, or we can copy from the upper one. We just copy from here our previous codes, and we just come here down and we paste here, but we need to change, instead of a Shapiro result we write here Wilcoxon result, and we again run the code, and this time it will nicely print our results. So we have a Wilcoxon results, statistics is an 18, and p-value it's showing a 1.5 into 10 to the power minus 5, so it's highly significant in Python. And stay tuned for the more insightful tutorials on statistical analysis and data visualization. Don't forget to like, share and subscribe for more content on the data analysis and the programming tutorial in Python. Thank you for your attention.